about that, and I don't have a Mac, so I can't answer that one. On Windows, if you don't install it on XP, it's not there by default, and on Vista, there is an option, but you'd have to Google for it. It might not be on by default. So the host OS generally doesn't care and doesn't do this. The applications do. So like some of the BitTorrent clients will by default go out and look for a UPnP device just so they can open the inbound port. So you really have to disable at the application level because the OS doesn't need to know this. It's really the applications that do. The OS just tries to be helpful from time to time.
This could be a dumb question. Is there a way that, for example, using stuff like IDP and IDS to detect UPnP, adding rules to my IP tables, for example?
Absolutely. And I probably should add it to my research because I didn't think about doing it. So if you look for msearch packets, you know somebody's doing this. This is so unencrypted, it would be ridiculously simple to just look for add port mapping. If you get an add port mapping sent to your device, it's going to work. And then, if you wanted to do kind of false positive detection, what you can do is, I didn't show it here, but if you look through the code, it's pretty simple to do, or just play with the device. You can request how many rules are there. It's one of the default UPnP methods that every router I've found seems to provide. And then you can ask for a specific rule. So all you have to do is ask for the current count and then ask for the last rule. And if that rule matches what you saw an add port mapping for, there was a successful port mapping sent. So, any other questions?
Hi, do you know this DNLA?
DLNA, yes.
Is it similar to UPnP?
So DLNA is, so the UPnP vendors who did IGD didn't really agree on what they should do, and there's some incompatibilities, and nobody seemed to implement the same thing. So DLNA is really the AV spec. So there's an AV spec called UPnP AV. DLNA is a bunch of vendors got together and said, we are going to implement these features of UPnP AV to support it. It's not in this slide deck. I am researching generically UPnP AV. It's vulnerable to similar things. They're mostly devices that have been rushed out the door based on reference designs. There's one really interesting feature that somebody else pointed out to me the other day in the AV profile. I forget the exact method name, but basically you can send informational messages like caller ID to somebody's TV set if it's doing DLNA as a AV renderer would be the class. So you can just annoy them. You can also send pictures. So in the middle of a movie, if you send the right packet, they have a picture of whatever you choose to show them on their screen. So yes, UPnP AV, same class of attacks. This toolkit will work for most AV devices, but I only have 2, so I haven't done a lot of testing. If you find devices it doesn't work for, send me the dumps. It would be helpful, or better yet, send me the devices because they're more expensive than routers. So any other questions?
Are NAT PnP devices better off?
Excuse me?
Are NAT PnP devices better off?
Are NAT PnP devices? So I haven't looked at the NAT PnP devices, and I haven't looked at like the stuns and the other like rendezvous protocols. I would suspect that most of them, since a little bit of looking I've seen, they don't have authentication methods. It's just a different way of agreeing on a port to share and allowing it to come inbound. So the package you would send would be different. I don't actually have any, but like I'd love to look at those too. I would suspect you can do almost the same techniques. Just find the device, send a request. You might have to forge it in that case, just because of how it works, but send a request on somebody else's behalf and say, I'm about to use this port and the response needs to go here. And I would suspect that it would go through relatively easily. So, anything else? All right, what I'm going to do is I have a couple more slides from the presentation I was talking about that I did in 2006. There's a little bit better context now. When I did this in 2006, I hadn't actually researched UPnP and SSDP at the time. I just kind of figured out that I had a device that had some weird boot methodology. So what I found when I did that was, let me pull up the slides for you. All right. So I created this project, which is also available, I think it's still on my website, called Project Cowbird. And basically what it did was I took one of these UPnP AV routers, or specifically a media renderer, and this is a really old one. They're about $30 to $70, which makes them cool from the throwaway device standpoint too. I figured I'd subvert it. So what I found when I was using the device, it had a ton of hardware in it for 30 bucks. And I got a Prism 2 card, I got video out, I got an infrared receiver, which I kind of have working for receiving V cards if you have a Palm Pilot, so I can just sniff, wireless infrared if I'm pointed at it. I've got Flash, I've got JTAG, I've got Ethernet. I can basically do what I want. And turns out the device uses SSDP to announce its presence. So it works a little bit backwards, where a lot of these devices will boot and they'll be looking for other services. So like specifically in like DLNA, what they're doing is you've got renderers and you've got like media providers, and the renderers wake up and they say, are there any providers out there that I can get data from? Well, this one instead says, hey, I'm available, can somebody boot me please? And then it sends like, hey, my boot URL's over here. Talk to this service and tell me what I should do. So what I did was I wrote a server that responded to its SSDP request and said, hey, yeah, I'll boot you. Here's the URL I want you to grab data from. And then I send it new data. So this is the perfect reason why you should sign your bootloaders and do something more intelligent with your code. Their boot images are very secure because they renamed CramFS to .img. So I built a custom boot disk for the device that runs the original client code and a Kismet drone. And the new version, which I haven't released yet, now uses UPnP to allow an inbound port so that I can connect to them and announces its presence to a home beaconing server. Because they didn't verify anything, they had no security, and like if you don't want to run my server, you can just modify the XML that tells it what file to boot and give it a new CramFS image. Two of these, a router, all the power plugs fit in a soft-sided lunchbox for carrying a 6-pack of beer. Amazingly, that gets through airport security too. So that's what I gave the last time I did this presentation off of. If I left that in your office with this device, and this goes to the, consumer devices are great for leaving at companies and not caring if you lose them. So I have one of these that's partially reflashed so that it doesn't need to boot off of the network and has an SD card reader-writer in it and runs off a battery pack. So if I left a lunchbox with 2 of these in your office, you might not notice it for a while, and I could capture data and then get it back later, or just transmit it out since I've got Ethernet and Wi-Fi. So at a high level, it's bad. It's 30 bucks, lots of hardware. I'm going to throw these away. I want to build one that I just duct tape to the bottom of somebody's car, let it drive around, capture packets, and transmit when it's actually got a stable connection. And I don't care if it breaks or I get lost. Same thing, consumer device. Think about what you need to do in the design. Sign the boot images so nobody else can do it. In this case, the solution is a little bit simpler. Make your media network private and make sure nobody can run the bootloader. The reality is fix the damn devices. And then I just, some other slides. This is the SD card enabled version with 40 wires that also made it through security amazingly. They looked at it 5 times though. So that's all I got for you unless there's any other questions. All right, thanks guys.